We define a function to be periodic if there is some number p that's positive such that f of t plus p is equal to f of t. In other words, if you can think of this in multiple ways. If you think about it graphically, f of t plus p, that's going to be the shift of f of t to the left p units. This says that if you shift it p units, then it looks the exact same. Okay. So that's what a periodic function is. It repeats itself. Okay. And the smallest such number p, okay, the smallest number that works here, we call the period of the function. Because our trigonometric functions are defined based on the points on a circle, okay, and we're just rotating around the circle, since the rotations around the circle clearly repeat themselves, our trigonometric functions will also repeat themselves. And so our trigonometric functions are all periodic functions. So the question is, what are the periods of the functions? What are the smallest such numbers that work in that repetition? So the periods of the trigonometric function. So I'm gonna just create a little table here and write what they are. So the function and then what the period is. Okay. The sine function. The sine is the y-coordinate. And as we travel around the unit circle, as we travel around, our y-coordinates start at 0. They get up to 1, back to 0, then they go down negative, and then back to 0, and then we start to repeat again. So our period of the sine function is 2 pi radians. The cosine is the x-coordinates. And the x-coordinates, well, we start out at positive 1, we get down to negative 1, and then we travel back up to positive 1, and then we start to repeat ourselves again. So the cosine function also has a period of 2 pi. Now, because the cosecant and the secant functions are just the reciprocals of the sine and the cosine, those will have the same period. Okay. Now, tangent and cotangent, something interesting happens. The tangent, remember that the tangent of an angle, you take the y-coordinate and divide by the x-coordinate. When we start off here, we have positive values for both of them. And so we think about this. This is 1, 0, and then up here is 0, 1. Okay, the y-coordinate divided by the x-coordinate starts out at 0, and then it travels up, and actually shoots off to infinity as we get closer to 0. Okay. When we jump over here and we have these values, now we've got negative x values. So when we take our y-coordinates and divide by those x-coordinates, we actually get negative numbers. Okay, really close, negative infinity, really close to this point here. But then traveling here, and then we get down to when y is 0, we get back to 0. Then when we get down here in the third quadrant, both coordinates are negative. And so when we divide them, we get the positive, the same thing that we got in the first quadrant. So it turns out that the period of the tangent function is actually just pi. It only takes a pi to get all of our possible values, and then we start to repeat as we go. And cotangent, of course, is the reciprocal of tangent, so it will also have a period of pi. Okay. Now, these are the periods, and this means that you can write this in all kinds of different ways. We could write that this tells us that the sine of x plus 2 pi, okay, is equal to the sine of x, right? If you shift by 2 pi, you still get the same thing back, right? We could do that with any of these. But we also have some different properties which doesn't matter how many times you add the period. If you add the period 10 times, you're still back kind of to your starting point. You'll still repeat. And so we have some nice properties that say that if you take a trigonometric function, which I'll call f, okay? I'm going to say for f, a trigonometric function, okay, with period f, with period p, okay, then f of x plus any number k times the period, all right, will equal f of x. Okay, if I add the period 1, 2, 3, 7, 129 times, that's not going to affect the output. It's still going to give me the same output as that. And that will be helpful to us when we're trying to evaluate trigonometric functions of numbers that are like way beyond one revolution around the unit circle.